Okay, so what we're going to do with section 1.2 is add variables. So let's just write down with variables. So here's a really, really common problem in math. 2x. That is 2 times x. Do you agree? Everyone agrees with that, I'm sure. That part's okay. We could also write this as x times 2. Which is not standard way to write it, but it's totally correct. There's nothing wrong with it. We could also write this as 2 times 1 times x. That's factored. You could write as many 1s as you want, and it would still be the same. It is not, absolutely, it is not x times x. But when people read 2x, sometimes they think of 2 x's. But it is not 2 x's. Okay? It is not 2 x's. It's 1x multiplied by 2, doubled. Okay, so be careful of that. That's a really, what is x times x? X squared. And you know that. I know that you know that, but when it comes to canceling, and you see this, so we're looking for a common mistake here, people will say there's x left, because there was 2 x's on top and 1 on the bottom, so the answer is x. I see it all the time. Like all the time. 90% of the people that write my final exam online do this in at least one of the questions. So even though you know it, I want you to really be careful of that. The 2, and this is how I try to explain it to make you not do it. The 2 is not attached to the x. It's not part of the x. It is not attached. When you have a number in front of a variable, it's not attached. Okay, it's not part of it. This is totally bad, really very wrong. What should it be? This is 2 times x over x. Same rule as with before. If there's something in common, we can cancel it out. N equals 2. Now there's another problem when you're canceling out variables, and what is that? It's called the domain. And if we cancel a variable, we have changed the domain. So what on earth does that mean? The domain is the numbers that work in the original question. So in this original question, there's no equal sign, so really we can put x as any number. I can put an x as 1. I can put an x as 2. I can put an x as 3. What's the x value that wouldn't work? 0. Why not? Because you can't divide by 0. Okay, so x cannot be 0 since dividing by 0 is not allowed in real numbers. We actually see it. You'll see divided by 0 working in calculus. They'll teach you about that. When does it work? Okay. But in pre-calculus right now we're saying it doesn't work. But that's not a rule forever. Okay. In real numbers it doesn't work. Later on there is a case where it does work. Okay. So we can't divide by 0. So if I then say this, if I plugged in x as 1, what do I get? 2 times 1 over 1. 2. Do you agree? What if I plug in x is 4? 2 times 4 over 4. Isn't that still equal to 2? Because the 4's will cancel. 4's cancel, so it's still 2. No matter what number I plug in, if I plugged in x as negative 100, I get 2 times negative 100 over negative 100. The negative 100s cancel, and I still get 2. So the answer to this is 2 for every x that we can plug in, except 0. We can't plug in 0. So when we take 2x over x and make it equal to 2 by canceling out the x's, totally cool, we're going to do that. We've changed the domain because now it's just 2 always. There's no x to plug in, so even if we said x is 0, it still works. We've changed the domain. We've canceled out that restriction that the original question had. And whenever you simplify a question, the original, and then we write equals, 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 we're saying they're all equal, no matter what. So as soon as you cancel an x out, you've now changed the numbers you can plug in. It's not the same equation. So to make it the same, we would usually just say that x can't be 0. So whatever restriction there was in the beginning, we just sort of write it at the end. Okay, so that's what we're looking for, and that's called a restriction. So we're just going to, when we cancel out an x, we're just going to write the restriction that was there in the beginning so that it's still there at the end. We didn't need to write it at the beginning because it was understood. The x was there, you wouldn't plug 0 in, it wouldn't work. We already knew that. But putting it at the end is sort of important. All right, so we're just going to do a couple examples. Same idea as we did before, just multiplying fractions and canceling things out. So we would write this as a big fraction. And the best way to do it is the same way I've been doing it, which is actually breaking it up. So we've got a 4 times x times 2 times y. That will eliminate that crazy mistake, canceling out an x. And here, y times y, that's y squared. Do we need to break the 8 down? Yeah, there is a 4 and a 2 on top, so if we break it down, we'll be able to cancel them. And x squared is x times x. And I've got little time signs between everything. Usually you won't have this many factors on top and bottom, but I'm just demonstrating what would happen. So the 4 cancels, the 2 cancels, an x cancels, and a y cancels. Looking carefully through, I see that there's nothing left on top, so just a 1. And on the bottom I've got an x and a y. Normally we'd put them in alphabetical order. Instead of yx, you'd put xy. We don't need the dot anymore, but it's still understood to be there. And did we cancel out x's and y's to change the bottom of the fraction? Or did it really? Originally, what could x not be? 0, because we don't want a 0 on the bottom. And what could y not be? 0. What about here? Still, we can't plug in x is 0, y is 0, so we actually didn't change the domain by canceling here. But you can always stick the restrictions if you want, just so you don't have to think about it. You can say, well, x can't be 0, whoops, and y can't be 0. You can put it. It's not wrong to write the restriction, but we actually would be okay not to, because we didn't change it. We still can't plug 0 into the bottom. It's usually when there's just the x is gone altogether that you would do that. Okay, let me just see what I've got here. 105x cubed y squared over 42xy cubed. So you can write all of these out and then cancel. And if you need to do that, you can just always do that. We're going to write it out for this one, but then I'm going to sort of stop doing that and show you a better way without writing them all out. In real life, though, you don't get this many factors. Now, 105 and 42, I don't see anything right away that goes into both of them. So you might just end up breaking them down, a little bit to see what happens. Like 42 I know divides by 2, half, that's easy enough. And we've got 1x and 3y's. So that would be the bottom. And maybe I want to break the 21 down, I don't know. What about 105? What goes into it obviously? 5. And so you could do long division to get that 5 out, but you can also look here. 5 goes into 10 how many times? 2, and 5 goes into 5? 1, so 21. That'll also work. Three x's and 2 y's. So what's left? Let's just cross them off. 21's, an x, 2 y's, and what we're left with is 5x squared and 2y. My question is, did we change the domain? What we couldn't plug in the beginning was x is 0, we can't plug in because that would make a 0 on the bottom, and y is 0, we can't plug in. Did we change it? Yes, we did. Y can't be 0, but x now can be anything because there's no x on the bottom. So you do need the restriction. X can't be 0 because the x we canceled from the bottom. It's no longer there. You could plug x is 0 into this equation and it will work because a 0 on top of a fraction is totally legal, just not on the bottom. So you'd have to put that, and while you're putting it, you could also say y can't be 0 because it can't, but it's not as necessary. Okay, so what we're going to do next class is expand on this. We're going to do common denominators and then cancel. So every time you do a fraction, if we do a common denominator, like subtract them, you then end up with a fraction that you need to do this to, always.